This next section is a collection of ideas which we've already seen before. We're just going to put them all together. So uh, we're doing this together in the sense of having the higher roots as well. So let me show you what I mean. So we have already seen that we've had fractions underneath the root. And what we saw is that we were allowed, let me think of something here. So if we had the square root of x squared over 9, we saw that we could turn that into individual roots, or vice versa. You can go back and forth between any way you want. Now we're going to do the same here. Now we have this already. It's underneath the one root. It isn't broken up into individual pieces. And when we have this, the goal is, can we simplify? And the answer is yes. If I had 8 a's on the top, 5 a's on the bottom, slashed all those down, I'd be left with 3. Now, if I've got 3 a's underneath, that's the same as we would lasso in the world of 3. We'd lasso an a and we could bring it out. So the same here with b. We can simplify underneath that root before we do anything else, and we'd get a to the 8th. Well, if we had 8 a's under there and then we're in the world of 4, we could bring out 2. Okay, so try these. We're going to simplify first, and I would be left with, see, I'd be left with 4 x's. That would let me bring 1 out. Here we would be left with, so I got 17 on the top, 5 on the bottom, I'd have 12 left. We're just subtracting. So, or you can just think of it visually, 17 on the top, 5 on the bottom. So if I'm in the world of 4 here, you see I could bring out 3. If I partnered them up, so you make them all if you need to, lasso them, or you can think of this is division. They all came out. Okay, more of the same here. This is going to be cube root of m to the 6th. Now if I had 6 m's, let me show you one again just in case you want to see it. Got 6 of them. Every 3 lets me bring 1 out. I could bring out 2. If I simplify this, I get n to the 10th. That simplifies down. If there were 10 of them, I can bring out 2. Okay, now they just get a lot crazier. So this is what I referred to in the beginning. We can go back and forth between individual roots and having them combined under 1. So we're going to put them back together under 1. And the reason is that we could then simplify this and make it negative. Just 1, it'll turn out to be the square root of negative 54, which is allowed. You could bring out a negative 3 and leave 2 behind. So remember how we would break 54 down. We would just do all the 3's, so it'd be 3 times 3 times 3 times 2. And now I know it was a negative, but I would bring out 3. And because it was a negative, I'm just going to put on that negative side. It was allowed to be a negative under there, so I'd have negative 3 cube root of 2. Again, we're going to use that trick. We're going to put them back underneath 1 root. We're then going to simplify. We get to here. Now if we break this down, you can bring 2. So let's do it. You've got 5 2's under there and 5 x's. We're in the world of 4 and x of 4. So I can bring out a 2 and an x. What's left on the inside is a 2 and an x that didn't partner up. Now they're using the absolute value thing again here, but I don't care about that. So let's try a couple. We're going to put this back under. And the reason we're doing this, turning it back into 1, is so that we can reduce that. So they're both even numbers, so we could divide that down. Am I right about that? 2. No, I'm not right about that. It would be negative 266, I believe. No, I still don't think I'm right. Okay, negative 266. All right, now we've broken that down so that we could take the cube root of that. It's allowed to be cube rooted, even though it's a negative, because we're in our index of 3. And I don't know the cube root of 266. I don't know if I could easily do that here. Hold on. Okay, I was hoping it worked out evenly. It doesn't, so let's break it down. So I'm going to have to do my house and all of my numbers there. Hold on, I don't see it. I'm going to pause it and find it. Yeah, that's a strange one. I think it breaks down to negative 266, and that's as far as it goes. So I'm going to let go of that one and come over here. So to be, we're going to put this back under 1. It's supposed to be an 11. Okay, so we're going to simplify this. I'm sure 3 goes into both of them. I'm going to let my friendly calculator help me with this. So I've got the 4th root of 162. Now I had 11 m's on the top and 5 on the bottom. I've got 6 m's left. Okay, so 162, I'm going to break this down. I don't know what that would be. Oh, that's going to be... Okay, so I actually do. So this is going to be... Now you've got 6 m's in here. I'm going to go ahead and do this. So remember how we match them up. So I could bring out a single 3, bring out a single m. So I had 2 m's on the inside that didn't match up, and the number 2. So that's what I would get. Okay, we're going to put this back under our roots. So I get, oh, so we need a cube there. So it is a negative 64, but because it's an odd index, we're allowed to do this. The cube root of negative 64 is 4. So you could break that down if you wanted with all the 2's, but it's allowed to be negative, so I just put a negative on it. Okay, now on B here, same thing. We're going to put it back underneath 1 root because it's going to be helpful to us. So I can simplify this down. I get 162. I get 4 n's left. So if I had 7 on the top, 3 on the bottom, I get 4 left. Now 162 is 2 times 81. Oh. 81 is made up of 4 3's. So you could prove this to yourself if you want, but I can bring out a 3, and I can bring out a single n. What's left in the inside is just a 2. Okay, more of the same, but we won't be able to simplify, I don't think. So we're going to see that we can't simplify, so now it's to our benefit to go ahead and split these up into 2. So now we just have 2 complicated, but problems we've seen before. We're just simplifying the cube root of 24x to the 7th, and we're doing the cube root of y to the 3rd, and we just get this. So the same, nothing simplifies here on B. So we're going to just turn it into 2 individual problems that we already know. Now we can break down these. It takes 4 of a kind to bring it out. Now it's not simple to do, but it's just as if we had a problem on the top and a problem on the bottom. We already know how to do those individually, and we would get this. Okay, so we'll try some here. I can't simplify this, so that would be the benefit of leaving it underneath there. So I'm going to go ahead and split it up. into just two problems that I already know how to do. So if I did 108, I don't know where the cube root of this is going, so I'm just going to start working on it. Okay, so I'm not going to write it under the house, but we're in the world of 3. So I can bring out a 3, and inside that's going to leave 2 times 2 or 4. If I've got 10 C's under there, I can bring out 3 of them, and 1's left behind. Now, d to the 6th here, I've got 6 D's under there. Pairing them up, I can bring out 2 of them. Okay, I don't know if I left myself enough room here for B, but we're going to split this into 2 different problems because nothing reduces. Got to be careful not to lose my index here. Okay, let's break this down. So AD is made up of oops, that's wrong. That's why I'm not getting that right. Okay, we're in the world of 4, so I can bring out a single 4. There's 4 2's here. So it leaves a 5 that didn't partner up and leaves a couple x's that didn't partner up. And on the bottom, 5 y's lets me bring 1 out. And leaves 1 y behind. Okay, just one more of these here. We can't simplify them, so we're just going to split them into 1 on the top and 1 on the bottom. Okay, this one's a little strange in that, so we did 40, but I don't remember what it was. Yeah, so it was 3 2's, so I can bring out a 2 and an R there. And what's left behind is a 5. And this is an S, don't let that confuse you. There is nothing I can do with that. Oh, is this what they're doing with this? Yeah, I think it is. Now, I'm not going to go there. I don't think we've seen this, so I'm going to stop here. But so we would need to rationalize this, and because we don't want the root on the bottom. But rationalizing this takes a new trick that I don't think we saw. So I'm going to just pause that there, and then I'll check to see if they're doing that in the book in the next section. But that's a little bit more than we're ready to handle. Okay, so this for B, we're going to split this into 2. Because it didn't simplify. Now the top, try it, trust me on this, but it's going to be, or check it out yourself. I am left behind with that. On the bottom, all of them come out. Okay, that'll finish that up. So it just simply, we split it into 2 individual roots because there's nothing to simplify. Remember, we can toggle back and forth between under 1 or individual ones anytime we want. And so that allows us to just simplify the top, simplify the bottom.